Hey guys, welcome to another one of my very helpful videos when it comes to maths. My name is Onka the Tutor for those who don't know me, but most of you know me. So yeah, let's get to it. Well, this goes out to the grade 12s, mostly, because you know, it's tough out here, right? You have to get your marks up. Most of you are trying to get into varsity. So today we are going to be tackling trig identities. Oh, trig identities. A lot of people are scared of these. They're like, oh, trig is tricky. No, trig is not tricky, guys. I'm just going to be showing you this. Yeah, we got to prove this. So, trig identities. First thing you have to know, basics. Basics. You have to know your ratios from grade 9. Yeah? And you have to know your basics from grade 10 and 11. So first thing you have to know is your ratios. You have to know the diagrams. You have to know a lot of stuff. You have to know. But mostly the most important thing that you have to know in grade 12s is the double angles and the compound angles, because when you break the identities down and you're trying to prove that the left hand side is equal to the right hand side, you have to manipulate it and you have to have all the equations at hand. You have to know all of them. You have to know how to break down cos 2 theta, because you can actually break it down into three. You can break it down in 3 ways. So first you look at the equation, how it is and what it consists of. So if it consists of mostly sine, then that cos 2 theta will have to be broken down into an identity that has sine, which is that one that has 1 minus 2 sine squared theta, because it also has 2 cos squared theta minus 1, but you're not going to break it down into that. You have to break it down into a sine. Okay? So here I have questions from an exercise from this textbook, Via Africa, Mathematics grade 12. Okay, so I'm just going to use this one and take just one of the questions here, okay? Okay. So, but before I do anything, yeah, I told you guys the most important thing you have to know. Let's start with what we learned in grade 10, yeah, which is sine squared theta plus cos squared theta is equal to 1. And also, this is an identity from grade 10. And also, tan theta is equal to sine theta over cos theta. This is another one of the identities. And I don't know if I should include this, but for the ones who are doing technical maths, we also have to include the cosines and the cosecs. Okay. So, and the cotangent, or the cot. So let's start with cot. Cot theta will be equal to 1 over tan theta, because they might as well just throw it in there, you know, because I've seen in so many instances where they actually throw it in, but the math is not technical maths, it's actually pure maths, and you're like, what, you know? And they actually have question papers. They actually mix the chords, the chords and the secs and stuff, so we also have to know these things. So sec theta is the same as 1 over cos theta. These are notes, guys, take notes. And cosec theta is the same as 1 over sine theta. Yeah? Yeah. So these are just grade 10 ratios. These are grade 10 identities. And there's actually more. There's more from grade 12. Those ones go like, we have double angles. Double angles. Which go like, oh, let's start with sine 2 theta. So it's sine 2 theta. This 2 just means that you are doubling the angle. So when you double the angle, it has its own identity. It has its own equation. Okay. So this is equal to 2 sine theta cos theta. Great. And we also have a double angle for cos 2 theta. This one can be broken down into 3 identities, right? First one is cos squared theta minus sine squared theta. Sort of almost looks like this one, the sine squared theta plus cos squared theta, but this one, when you add them, they will be equal to 1. But this one, when you subtract them, when cos squared theta subtracts sine squared theta, it gives you cos 2 theta. Great. And then we have another one. This is also equal to, so cos 2 theta is also equal to 2 cos squared theta minus 1. And it is also equal to 1 minus 2 sine squared theta. Guys, you just have to know this. You just have to know this, because if you don't know all these identities, it will trig you. Like you said, trig, right? So these are the ammunitions that I told you about earlier that you have to know before you start any calculations. Alright? And if it gives you tan 2 theta, well, this one is actually quite simple. It's just like tan theta is the same as sine over cos. So tan 2 theta will be the same as sine 2 theta over cos 2 theta. Great. And depending on how the question looks like, you can break this down and manipulate it into how you want it to look like, or how the answer ends. Right? So I know you took notes, so I'm just gonna erase this real quick. Start with the calculations. Great. So we have a question here. It says we have to prove that sine x over 1 minus, what is that? Cos 2x is equal to 1 over 2 sine x. We have to prove this. We have to prove that this side is equal to that side. So what we have to do, this is the left hand side, and that's the right hand side. So first thing we're going to do is that we're going to take the left hand side. So we're going to take the left hand side and manipulate it, change the identities so that it ends up looking like 1 over 2 sine x. Right? So we can't change sine x. We can't change that. It doesn't have an identity. So what we can do is we can change this one if we have to do that, and we can change the cos 2x, yeah? Because the cos 2x is a double angle, and you can change it in three ways. And this you can change it in one way. We remember that sine squared x plus cos squared x is equal to 1. Remember that, right? So we can actually change this one into sine squared x plus cos squared x. Yeah. But we have to plan this. We have to plan this correctly. Okay, let's see. The sine x, we can't change it. Okay, so let's try and change. The first thing we're going to change is this cos. Okay, so let's change the cos. We have to change the cos into something that has sine. I told you, when say you have your answer has sine at the end, and you have an identity like cos 2x. Remember, you can change cos 2x into 2 cos squared x minus 1, or into 1 minus sine, 2 sine squared x, or that cos squared x minus sine squared x. You can change it into, you have to choose between the three. So, but because your final answer has sine at the end, you're gonna have to scratch this one and this one, because this one has cos and this one has cos. So we're not trying to do that. We're trying to end up having a sine at the end. So you change everything into a lot of sines, okay? So we're gonna change this cos 2x into, remember, because it has two terms, you have to put it in a bracket. So it's going to be 1 minus 2 sine squared x, alright? And we have to multiply each term inside the bracket by, we have to multiply it by minus 1. So minus 1 multiplied by 1, positive 1 is negative 1, and then minus 1 multiplied by minus 2 sine squared x is positive, because negative times negative is positive. So it's going to be positive 2 sine squared x. Great. So 1 minus 1 is 0. So these ones they're gonna cancel out. So we're gonna be left with sine x over 2 sine squared x. Alright? Sure. Let me just erase this. Hope you can see it. Let me just check real quick. See it? There it is. Sine x over 2 sine squared x. Awesome. So alright. So let me just erase this real quick. Sharp. So we are left with, let me rewrite it over here so that all of you can see. Awesome. So this is the same as sine x over 2 sine x. So sine squared x is the same as sine x multiplied by sine x. So it's like sine x. Alright. So sine x goes how many times into sine x? One of the sine x's are going to cancel out, and at the numerator you're going to be left with 1 over 2 sine x, because you have 2 multiplied by sine x, which is the same as 2 sine x. So guys, there you have it. See, that was just one example of the trigonometric identities. Stay tuned for other videos on other topics, on other chapters, because I will be having your back throughout this year and the following years. Thank you for watching.